Welcome dear friends, another topic we are studying today, and we will also begin with the new chapter, that is on measurement of pressure. In measurement of pressure we will study first atmospheric pressure, then pressure definition, pressure references, then the pressure, what is meant by pressure, then measurement of pressure, pressure head, Pascal's law. Again we will study the concept of specific gravity, specific volume. Again we will study the atmospheric pressure. What do you mean by pressure gauge? What is gauge pressure? What is absolute pressure? What is negative pressure or vacuum pressure? All these concepts or all these terms that we are going to study in the today's lecture. And similarly we will introduce the manometers, different types of manometers, that is simple manometers and differential manometers. So let us begin with the today's topic, that is pressure. The atmospheric pressure. Atmospheric pressure, the land is composed of 29% and the water is composed of 71% of the earth. The earth is surrounded by the atmosphere up to an altitude of 100 km, and 9/10 of mass of atmosphere is contained below the altitude of 20 km and 99% below the 60 km. The life on the earth is confined to the biosphere, which extends to the altitude of 1 km. In the troposphere, temperature, pressure and density of the air drop with increasing altitude. So this is the pressure references. If you find this is atmospheric pressure. What is atmospheric pressure? What is atmospheric pressure? We have already studied. It is 76 centimeter of the mercury or 10.33 meter of water. 76 centimeter of mercury that we have already studied in our school days, and 10.33 meter barometric pressure that we have studied as a torricelli barometer. And there are another type of barometer, it is an aneroid barometer, that also measures the atmospheric pressure. Whatever the pressure measures above the atmosphere, so it is the gauge pressure, and whatever the pressure which is measured below the atmospheric pressure, it is known as vacuum pressure or negative pressure. And where the absolute zero, that is the zero pressure point, that is known as the absolute zero reference. So whatever the pressure that we are measuring with respect to the atmospheric pressure, and the atmospheric pressure lies above the absolute pressure. Whatever the pressure lies above the atmospheric pressure, it is gauge pressure, and whatever the pressure lies below the atmospheric pressure, it is vacuum pressure or negative pressure. So let us introduce the concept of pressure. The pressure in a liquid does not depend upon the size or shape of the container. The pressure in a liquid acts equally in all directions. Pressure at all points, at all depths are equal, and the pressure exerted increases with the depth of liquid. That we are going, the fourth point that we are going to study in the next chapter, that is based on the hydrostatic pressure. The pressure at a point in a fluid continuum is defined as the normal compressive force per unit area at that point, and in other words, the compressive normal stress is referred as the pressure. So P is equal to minus sigma. It would be noted that the fluid can be withstand high compressive stresses or pressure, but it is weak in tension. Pressure is weak in tension, but pressure is strong in compressive stresses. It is for the reason that the pressure in fluid is always referred above the absolute value, since the negative absolute pressure would imply the tension. So force per unit area is the definition that we have already studied in our school days. The pressure is a force per unit perpendicular area which the force is applied. In equation form, the F is equal to P, small p is the pressure intensity into area. So force, that is Newton, is equal to P, that is Newton per meter square, into area, that is also meters square. So Newton upon meter square, and area is meter square. So meter square get cancelled. So P becomes, that is F. So F is also in Newton, and this right hand side is also in Newton. So this is dimensionally homogeneous equation. So F is equal to P into A. The SI unit of the pressure is Pascal. 1 Pascal is equal to 1 Newton per meter square. Pressure is the weight of the fluid. So F is equal to mg, which is divided by the area supporting it. So P is equal to F upon A. So measurement of pressure, the normal force exerted by the fluid at a point per unit area of the surface is called the pressure intensity. Pressure intensity is always given as Newton per meter square, Newton per centimeter square, or dynes per centimeter square, or unit pressure, specific pressure, or hydrostatic pressure. If an elemental area dA of the normal force is exerted by the fluid dP, then pressure intensity P is equal to small dP upon dA, and when we integrate it, so it is total pressure, so that is P is equal to integral of P into dA. So this is the Newton per meter square, the limit of integration being taken to cover the whole area, because dA is elemental area, and when we consider the total area, that is capital A, so P is equal to integral of P into dA, which covers the whole area, and the units of the pressure is, this is old unit, that is kg per meter square, but in SI unit we will use always Newton per meter square, Newton per millimeter square, or dynes per centimeter square. This is the correct way of giving the dimensions to the pressure quantity. Kg per meter square and kg per centimeter square, they are the old style of units, so you can ignore those. And Newton per meter square, Newton per millimeter square, or dynes per centimeter square, or Pascal, they are the SI units. Now let us understand what is pressure head. So let us consider this container and the depth is H. The pressure force exerted on the elemental area, that is, this is dA. So P is equal to weight of the cylinder on the area dA. So W specific weight, dA is the elementary area into H. H is the height of the column. So intensity of pressure on the elemental area is P is equal to force upon area, which is equal to W into dA into H upon dA. So which is equal to WH. So pressure intensity is always W into H, whereas pressure head is equal to H is equal to P by W. Remember this thing. P is equal to WH is always Newton per meter square, and H is equal to P upon W is always in H, in meter. That is, we also define, or we also consider as potential head. Unit is 1 Newton per meter square is equal to 1 Pascal, and 1 bar is equal to 100,000 Pascal. Now next we are going to start with the Pascal's law of fluid pressure at a point. Pascal's law states that the intensity of pressure at a point in a fluid at rest is always same in all directions. So let us consider the elemental prism ABC, the fluid in the mass. Let us ds be the thickness of the prism. P1, P2, P3, they are the pressure intensities acting on X, Y, Z directions respectively on faces AB, BC and AC. Let face AB is horizontal and BC be the vertical, and AC be making angle theta with the horizontal. So force on the face AB is equal to P1 into AB into ds. BC is equal to P2 into BC into ds, and P3 is another mutually perpendicular, that is AC into P3 into AC into ds. The forces acting are in X, Y and Z direction, and they are mutually perpendicular to each other and the form of system of the equilibrium. So resolving vertically, P1 into AB into ds is equal to P3 into AC into ds cos theta. Okay, so but AC cos theta is AB, so P1 is equal to P3 here. Resolving horizontally, P2 into BC into ds is equal to P3 into AC into ds into sin theta. So here AC sin theta is again PC. So therefore P2 is equal to P3. When P1 is equal to P3 and P2 is equal to P3, therefore P1 is equal to P2 is equal to P3. Thus we can say that the intensity of fluid at rest remains same at all points. Hence it is proved that is the same pressure we will find, or the same level we will find in all the containers. So hence the pressure at point when the fluid is at rest is same in all directions. So this proves the Pascal's law. The concept of specific gravity already we have studied in chapter number 1. This is the ratio of the specific mass of the fluid, that is mass of the fluid per unit volume, to the specific mass of the water, or mass of per unit volume at 4 degrees centigrade at mean sea level. So specific gravity of the fluid is density of the fluid upon density of pure water. So let us say the density of the fluid, let us say oil is 800 and the mass density of pure water is 1000. So 800 upon 1000. So 0.8 is the specific gravity of that oil. Similarly, the density of the mercury is 13,600 kg per meter cube and density of pure water is 1000 kg per meter cube. If we take the ratio 13,600 upon 1000, so that will be 13.6 is the specific gravity of the mercury. Concept of specific volume, again we have already studied, it is a reciprocal of specific weight, and specific weight is equal to W is equal to rho into G. Atmospheric pressure, a huge layer of atmosphere surrounds the earth. This atmosphere will therefore exert some pressure on the earth, and the pressure which caused by the atmosphere is known as the atmospheric pressure or the barometric pressure. So here this pressure references we are studying. So here it is absolute zero. Absolute zero means it is total vacuum. So which is equivalent to 10.33 meter of water using Torricelli's barometer or 76 centimeter of mercury. Whatever the pressure we are measuring above the atmosphere, they are known as the gauge pressure, and whatever the pressure at point P, that is below the atmosphere, it is known as the vacuum pressure or the negative pressure. And absolute pressure means absolute zero means total vacuum here. Atmospheric pressure may be expressed in terms of pressure intensity, that is 1.033 kg per centimeter square. This is old unit. Now this can be ignored nowadays. So better you use this unit 1.053 kilonewton per meter square. As the pressure head is 10.33 meter of water or 76 centimeter of mercury. 10.33 meter of water, that is we have already come across the Torricelli's barometer in our school days, and 76 centimeter of mercury or 760 millimeter of mercury. It is also defined as 760 millimeter of mercury also. Pressure gauge, it is a device adapted for measure the pressure at a particular point or the difference between the two pressure points. So they are the pressure gauge. Pressure gauges may be a manometer type or the mechanical gauges also are employed. In my background you will find the pressure gauge, that is a mechanical pressure gauge. Gauge pressure means whatever the pressure records above the atmosphere, that is known as the gauge pressure. And absolute pressure, when the pressure is measured above the absolute zero, that is or the complete vacuum, is known as the absolute pressure. And the negative pressure or the vacuum pressure, it is a point or the pressure point which is less than the atmospheric pressure and is known as the vacuum pressure or the negative pressure. So let us consider this diagram here again. Here this point A and point B. So point A is above the atmospheric pressure, so therefore it is the PA is a gauge pressure, and whereas the point B is below the atmospheric pressure, so it is the vacuum pressure at B, which is measured by using vacuum gauge. So this is pressure gauge above the atmospheric pressure and vacuum gauge below the atmospheric pressure, or it is known as the negative pressure. Then measurement of pressure, we can measure the pressure by using manometers and mechanical gauges. Manometers are two types: simple manometers which is connected to the point, and differential manometers which gives the difference between the two pressure points. So simple manometer, one end is connected to the gauge point and another end is free to the atmosphere. So three types of simple manometers are there: piezometer, U-tube manometer, and single column micromanometer. It is the micromanometer. Then piezometer, U-tube manometers, single column manometers, and the differential manometers, that we are going to study in my next lecture. Today I will conclude my lecture here itself. Thank you. Friends, in today's lecture we have studied the atmospheric pressure, pressure references, pressure definition, then measurement of pressure, Pascal's law, then proof of Pascal's law, specific gravity concept, specific volume concept, pressure gauge, vacuum gauge or negative pressure, absolute zero, and introduction to the manometers. These aspects we have studied today. In next lecture I will start with the new topic, that is the different types of manometers, that is simple manometers, differential manometers, and mechanical gauges. And later, after that lecture, we'll start with some numericals. Thank you. Please subscribe, like this channel, and if you would like to give any comments, you can express your views in comments also.